Hello everyone. Today we are going to discuss Ramachandran plot for our given protein. We have given a PDB ID 1COH. The protein details the protein we are going to use is hemoglobin. It's the structure of hemoglobin in the deoxyquaternary state with ligand bound. And the structure its ribbon structure is shown here. I have I have I have screenshot this structure from the PyMore, which I will tell you in the later sessions how to use PyMol and take the screenshot of the structure, different types of structures. So let's do our task. So we search for mob mol probability. Click on this. Here we paste our PDB ID. Mine is already there, so just then click on fetch. It's turning. Wait for some seconds. Click on continue. Now we have to add hydrogens in our structure. So click on this. Make it everything as default. Start adding hydrogen. It will take some time, I guess. Yeah, it's done. Regenerate, then continue. Then analyze all atom contacts and geometry. So all we need is Ramachandran plots. All are in defaultly checked which the data which we needed. So click run program to form this analysis. This will take some time, I guess. There are so many operations to do for. So our task it is doing its job. Let me define what we are going to do today. Basically, we are going to get a Ramachandran plot, overall plot of the protein, overall Ramachandran plot, and from the data plot we make a plot in the Excel sheet of different phi and psi values for beta sheets, for alpha helix, and for loops structure of the protein. Then we are going to compare it with the general plot, and we will see it that all the three plots that we have plotted are in the allowed region or in the disallowed region of the Ramachandran plot. I hope you all have understood this. Let's wait it for a second to. It's taking time. Yeah, it has come. So the data which is of our need is these all they are the PDF files. So I will click on this. It will open in just a while. Yeah, these all are the Ramachandran plots, different types of Ramachandran plots we needed. We will basically pasting this general case Ramachandran plot and comparing it with our plots. And the data we needed is from Ramachandran distribution Z score analysis. Yeah. So in this case, we have H is for alpha helix, L is for loops. In our protein, I think there is no sheet structure. Sheet If there is sheet structure, it is represented by S. So what we will be doing, we will basically copying where any H starts and it ends at this side. So we'll copy that data. We'll paste it. Similarly, we will do for L. We have to do only for once. So where is L? There is. But make sure the values are sufficient so that we can make a graph of it. Copy and I will paste. Yeah. This is for loops and this is for H helix, alpha helix. I will plot a graph of it. I have already plotted the graph for it, the data. I will show you here because manually it will take time to make the graph. So I plotted it here. This is the one. Yeah. So this is for psi and pi value for alpha helix, and this for loops. For alpha helix, the graph is this. For loops, it is this. So I'm just going to copy from here. For making the graph, you just need to open the Sheets app, paste your data, pi and psi values, select all of it, click on Insert, then click on Charts. Then automatically the chart is created. Let me show you for an example again. Yeah. From chart type, you have to select scattered data. Make sure to select scatter type. Here it is. Yeah. Yeah, there. So I just delete this as I have already made it. Yeah. This is one. I've copied it. I will paste it here. Will paste the unlinked portion. The chart is here. Then for the data 2, that is loops, paste unlinked. Since our since our protein structure don't have beta sheets, so there is only two graphs. Now I am going to paste this. I will zoom it and take a screenshot of it. But from print screen button. Then I will paste it here. Crop it so we can see clearly only this portion of it, which is of our interest. Then this, and it finally this. Just bigger the image. Yeah, it should be at the bottommost. Should be here. I just bigger this size again. Yeah. So what we have to do, we have to find out all the data that we have plotted. is in the allowed region or not. What is the allowed region? Allowed region is this outer line you see now. These outer lines, these. This is the allowed region. 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 But this is not the allowed region. This since it is outside of this curvature type region. So we just see the range. Like for alpha helix, it is from -50 to 0. -50 to approximately, if we see 5 values from -50 to -80. So we see it here. General case 5 values from 0 to -100. One is set to 100. So 0 to -100 it is covered, and in between this -80 will come approximately, 60 will come here, 50 will come here, 10, 20, 30, 40, 50. 50 will come here, and 60, 120 will come here. So 100 will come here. So here to here region is kind of this to this. Some part of the, at least 20% part of the region is outside. 0 to -100. 60, 50. Not that much part is outside actually. Here it is 60. Here it is 0 to 100. It can go from here approximately here. It is from 0 to -100, and we have to see -50 to 6, -50 to -80. So -80 something come will here approximately 60, 70, 80, -80, and -50 come approximately here. Some part of the data can be outside. So let us check again. Yeah, so some points can be outside, and in this loop and loop versus in this loop part we can see the range -50 to -50. Wait, 100. It will approximately 120 to 130. 130, and it is from -50 to 160. -50 to 160 it will come here, and the main part is this region. It is from -50 approximately 40, you can say, -40 to -130. -130. So some approximately here 1 2 1 2 3. These will be here 0 60, 60 to 120. So 60 to 120, 50, 60 to 120. Approximately 1 point will be outside. Yeah, 1 point will be outside. So that is not that much data. We can say approximately 10% is in disallowed region, and all 90% is in the allowed region. All this. And in this case, we can say 20% is in the disallowed region, and Remaining 80% is in the allowed region. So this our task is complete. Final task. Thank you.